Hello students, today we are going to learn about zeros of a polynomial and few of its application. For this, first of all, let us take some examples of polynomial and find some value. Here the first question is given px equal to 2x minus 5. Here you will have to find the value of p1. So for this, in place of x, here we have written 1. So this x will be replaced by this value 1. So that way, if we write 2 into 1 minus 7, then the value will be 2 minus 7, and which is minus 5. So value of p1 is minus 5. Similarly, in the next polynomial, it is given px equal to x plus 2. Now we have to find p minus 2. That means in place of x of the given polynomial, we have to write minus 2 and simplify. So let us do that. Here we are writing minus 2 and then plus 2. So minus 2 and plus 2 will become 0 here. Third polynomial is given fx equal to 3x minus 2. Here you have to find f 2 by 3. So here also in place of x we have to write 2 by 3. Then 3 into 2 by 3 minus 2. Now this 3 and 3 will be cancelled out. So then left 2 minus 2, which is 0. One more example of polynomial, py equals to given 12y. So there you have to find p0. So 12 into, in place of y, here 0. So here also y will be replaced by 0. 12 into 0 is 0. Now see, in the second, third and fourth polynomial, putting some number, we have got 0. Here we have put minus 2. So putting minus 2, we have got 0. In the next polynomial, putting 2 by 3, we have got 0. Then here in the third polynomial, putting 0, we have got 0. So this kind of numbers for which one polynomial becomes 0, that type of numbers are known as 0 of that particular polynomial. It means for this polynomial, minus 2 is 0. For this polynomial, 2 by 3 is 0. And for this polynomial, 0 itself is 0. So zeros of a polynomial, this is not only 0, actually it is one number. So that number can be positive also, it can be negative also, it can be fraction also, and it can be 0 also. So for that particular number, after simplifying, the polynomial becomes 0, and that is why that number is known as zeros of that polynomial. So here we have written the definition: 0 of a polynomial. Px is a number c such that pc equal to 0. So for this number c, the whole polynomial becomes 0, and then this c is known as 0 of that particular polynomial px. Now in exercise 2.2, question number 3, some polynomials are given along with some number nearby the polynomial. Now we have to verify whether the given number is 0 of this polynomial or not. So for this we have to put the value which is given there in place of x of the given polynomial. After simplifying, if we get 0, then the given number will be 0 of this particular polynomial. So let us see. Here it is given x equal to minus 1 by 3. So if we put this and simplify, so then we will get p minus 1 by 3 equals to 3 into minus 1 by 3 plus 1. So simplifying, this 3 will be cancelled out, minus 1 left plus 1, so equals to 0. So then we'll write, therefore minus 1 by 3 is a 0 of the given polynomial. Fourth number, the polynomial is given px equal to x plus 1 into x minus 2, and here x is equal to given minus 1 and 2. So two values are given. We have to verify for both whether they are zeros of this given polynomial or not. So let us take minus 1 first. P minus 1 equals to minus 1 plus 1 into minus 1 minus 2. So this will be 0, 0 into minus 3 equals to 0. So therefore minus 1 is 0 of the given polynomial. So then similarly the next number, for x equal to 2, p2 equals to 2 plus 1. Here in place of x we have written 2 plus 1 and 2 minus 2. Then 2 minus 2. Then this will be 3 into 0, 0. So therefore this is also 2 is also 0 of the given polynomial. Sixth number, px is given lx plus m, where x is minus m by l. So here also in place of x we will write minus m by l. So l into this is x, here we will put the value minus m by l, and then plus m. So here l will be cancelled out, then minus m plus m left equal to 0. So therefore this is also 0 of this given polynomial. So in this kind of question we have learned how to verify the given number is 0 of the given polynomial or not. Somewhere instead of 0, if we get some other number, then the given number won't be 0 of the given polynomial. Now in the next question we will learn how to find 0 of a given polynomial. So for this, say these few examples are taken here. So the first one is given px equal to x minus 5. To find 0 of the given polynomial, what we will write? To find 0 of px, we will write px equal to 0. So value of px is x minus 5, then x will be equals to 5. So this is the 0 of the given polynomial, This is the answer. Next number is given px equal to 2x plus 5. Same process. Px equals to 2x plus 5. So to find 0 here, we'll write px equal to 0. That means 2x plus 5 equals to 0, and then 2x equals to minus 5, and x equals to minus 5 by 2, which is the 0 of this given polynomial. Similarly, you can see the third example. Px is given 3x. So to find 0, we'll write px equal to 0. Then 3x will be equal to 0. And then x equals to 0 by 3, which is 0. So therefore, the 0 of this polynomial is 0 itself. Fourth number is given px equals to cx plus d. So to find 0 of px, we'll write px equal to 0. So cx plus d equal to 0. Then cx equals to minus d, and x equals to minus d by c, which is the 0 of this given polynomial. Now we learn division of a polynomial by a binomial. For this, let us take one example. This is one polynomial, cubic polynomial, 7x cube minus 2x square plus 5x plus 3. This we need to divide it by x plus 2. So for this, first of all, we have to see the highest term, that is 7x cube, and here in the binomial, this the term having highest degree is x. So first we have to divide this 7x cube by x and see what we get. 7x cube by x, if we cancel 1x, 2x left out, and that will be 7x square. So our first term would be 7x square, that we will have to take here. So we'll take here 7x square. Now with this 7x square, we have to multiply both this term x as well as 2 also. Now if we multiply 7x square with x, this will be 7x cube, that will write below 7x cube, and plus 2 into 7x square, that will be 2 7s are 14, so 14x square. So we'll write below x square only. So it is plus 14x square. Now as the process of division, we have to subtract this part from the previous one. So remember, when we subtract, then that sign will change. Sign means this plus will become minus, and this plus will also become minus. Now this 7x cube plus and this minus 7x cube will cancel out. Now here minus 2x square, and here this is minus 14x square. So minus 14 and minus 2 will become minus 16x square. That will write here, and then plus 5x will come here as it is, plus 5x. Now again minus 16x square, first we divide by x, and let us see what term we'll have to take here. So we'll write here minus 16x square and divide by x. So here also if we cancel 1x, so minus 16x left out, so we'll take minus 16x. So in quotient we'll have to write minus 16x. Now this minus 16x will multiply with both x and plus 2. So minus 16x into x will be minus 16x square, that will write here, and minus 16x into plus 2 will be minus 32x, that we have written below x. So remember, when we write this, the terms should be below like terms only. So now again we'll have to subtract. While subtracting, the sign will change. This minus will become plus and this minus will also be plus. So these two terms will cancel out. Then plus 5x and plus 32x left out. So then 5 and 32 will be 37x. Then again we'll take plus 3 here, which was left out. Now in question, what term will take? So for this, again 37x will divide by x. Then we'll come to know. So 37x by x, 37 left. So now we'll have to take 37 in the quotient. So plus 37. Now 37 will multiply with both x and 2. So 37x will come here. Then plus 2 into 37. 74 will come. Then we have to subtract again. The sign will change. Minus, this is also minus. So this will cancel out. 3 minus 74. So minus 71 left out as a remainder. So this is the process. This is one polynomial given. We need to divide this by this x plus 2. First we will divide this term by x, then we will come to know which one term we will take in quotient. And then after getting this we will have to multiply with both, and then we will put here and we will go ahead accordingly till we get a term which is less than x plus 2. Term means how we identify which is lesser than x plus 2 or not. So for this we will have to see the degree. The degree of this remainder must be less than the degree of the divisor by which we divide. So this is the process. Let us take one more example. We have to divide 8x square minus 5x plus 2 by 2x minus 1. Earlier in the previous example, it was only x plus 2, x has no coefficient, and here we have taken another example where x can have coefficient, say it is 2. So in that case what we'll do, process would be same. First we will divide 8x square by 2x to get the term what we'll take in the quotient. So 8x square, if we divide by 2x, then we'll get 4x to 8. If we divide by 2, 4, and then x. So this 4x we'll have to take here. So then it will be 4x. Now 4x will multiply with 2x as well as with minus 1. Then we'll get 4x into 2x will be 8x square minus 4x into minus 1 is minus 4x, that will write here. Then we'll subtract. Subtracting, the sign will change. This will be minus, this will be plus. So plus 8x square minus 8x square cancel out. Then minus 5x and plus 4x. We have minus 1x left. Then this plus 2 will come down. Now degree is 1 here and the divisor's degree also 1. So once again we have to take what term will take in the question. So again, minus x divided by 2x, that will write here. Then this x cancel out, minus 1 by 2 left. So minus 1 by 2 will take as a next term of the quotient. So that will write here minus 1 by 2. Now this minus 1 by 2 will multiply with 2x as well as minus 1. So minus half into 2x, this 2 and 2 will cancel out, minus x left, that will write here, and minus half into minus 1 will be plus half, that will write here. Then we'll divide this, we'll have to subtract this part from minus x plus 2. Then sign will change, minus x plus x will cancel out, and plus 2 and minus half, that will have to write here. Half will have to subtract from 2. So if there is a problem, you can write here and do first 2 minus half, LCM will be 2, then 4 minus 1, that will be 3 by 2. So 3 by 2 will be remainder. So this is the quotient and this is the remainder. Now to get this remainder by dividing one polynomial by another one, we'll have to divide by this method, which is called long division method. We have done this one here, then this is another one. Apart from this, there is one more process, that is remainder theorem, by which without dividing one bigger polynomial by one binomial, we can get the remainder, and that is called remainder theorem. Let us see the remainder theorem now. Let us see about the remainder theorem. Let px be any polynomial of degree greater than or equal to 1, and let a be any real number. If px is divided by the linear polynomial x minus a, then the remainder is pa. It means the polynomial is given, we need to divide this by x minus a, and then this theorem tells us that the remainder will be pa only. That means in place of x, if we put a and simplify the polynomial, whatever value we get, that will be the remainder. So for this, let us see this given example. Px is 3x cube minus 2x square plus x minus 5, and we need to find remainder when it is divided by x minus 2. So x minus a, x minus 2, it means a is 2. So in place of x, we will have to write the a as 2. So now let us see p2, that means x will be replaced by 2 in this polynomial. So we'll write 3 into 2 cube minus 2 into 2 square, then plus 2 and minus 5. So this minus 5 we have written. Now we'll have to simplify. 3 into 2 cube is 8 minus 2 into 2 square is 4 plus 2 minus 5, then 24 minus 8 plus 2 minus 5. So 24 and plus 2 is 26 minus 8 minus 5, 13. So 13 will be the remainder. if we divide this polynomial by x minus 2, we can verify this also. Now for verification, one example already we have taken for division. Let us take that only to verify whether the theorem is matching or not. In this question, this polynomial we have divided by x plus 2 and we got remainder minus 71. Now here if we use remainder theorem, let us see what we get. So this is the given polynomial px. We will divide this by x plus 2. So x plus 2 will compare with x minus a. So px is this one and x minus a is x plus 2. So minus a equals to 2, that means a equals to minus 2. So now this value of minus 2 will write here in place of x. So we'll write by remainder theorem, remainder equals to pa, that is p minus 2, because x minus a equal to x plus 2 means a equal to minus 2. Now this minus 2 will put here in place of x. So let us see, 7 into minus 2 cube minus 2 into minus 2 square plus 5 into minus 2 and plus 3 here. After simplifying, we can get p minus 2 is minus 71. So therefore remainder is minus 71. So this is the shortcut way to find the remainder. Whereas this minus 71 we can get by the long division method also, that we did here in this way. So remainder will be same, but this way we can get it easily. Thank you.